In this section, let's take a look at how we would use a calculator to evaluate inverse trigonometric functions. When we have angle measures that are anything other than our special angles, we will need a calculator in order to evaluate inverse trigonometric functions. So let's take a look at a few. Part A, evaluate in degrees inverse cosine of negative 0.4. So I'm going to write it down, cosine inverse of negative 0.4. And what I'm looking for is the angle measure in degrees. This is going to be an angle measure in degrees that I expect to see between 0 and 180 degrees that would produce a cosine of negative 0.4. Now I don't know what that angle measure is going to be. That's why I need the calculator. But I do know that between 0 and 180 degrees is in either quadrant 1 or quadrant 2. Now because this output is, or input for the inverse function, output for the cosine function, is a negative number, I'm going to expect an answer, an angle measure in quadrant 2, because that's where cosine would be negative. So let me put this into the calculator. And when I did that, I got 113.5781785. And it doesn't tell me how much rounding to do. Let me just go ahead and round to 2 decimal places. That gets me 113.58 degrees. Normally these problems would tell you how much rounding. In this particular case, it doesn't, so you just decide what you want to do. Now, let's talk about on that calculator how I got to the cosine inverse. Cosine inverse, you may notice on the keypad here, is listed in blue above the cosine key. To get to anything in blue, I have to hit second first. So I hit second, cosine inverse, and negative 0.4. My calculator, you'll notice up here at the top, was in degrees. I want to make sure of that. And so I got that answer of 113.58 degrees. Good, that makes sense. Let's go to the second one. The second one says evaluate in radians the arc sine, which is the same thing as inverse sine, of negative 3/5. Now, I am looking for the angle measure in radians that is going to produce a sine of negative 3/5. Now, remember for the sine function that I expect that output to be between negative pi over 2 and positive pi over 2. So let me just erase what I had here for the cosine, and I expect an output here either in the first quadrant or the fourth quadrant. And because that arc sine is negative, I'm going to expect that I see something in that fourth quadrant. So let's go to Desmos now and see what it says. It tells me that inverse sine of negative 3/5 is equal to, sure enough it is a negative number, negative 0.64350110088. I'm going to call that 64, negative 0.64. Just go ahead and round to 2 places. Now, Desmos is a little bit faster. Most of the time you are on the main menu. In order to get to the inverse or arc sine, you want to switch to the function, and then you will see the inverse sine. You also, of course, want to make sure you're in the right mode, which is radians. Okay, let's try the next one. The next one is inverse tangent. So tangent inverse of 6. And when I did that one, I got in degrees, looks like I got 80 point, I'll round to 2 places again, we'll call that 54 degrees. Now, do you remember what the angle output should be for tangent? Well, tangent is the same thing as sine. It is that boundary between, in this case it's degrees, so between 90 degrees and negative 90 degrees. Because the tangent output or input in this case for the inverse is positive, I did expect to see an answer in the first quadrant, and sure enough it is. One last one, let's do sine inverse sine inverse of 1.37. What does that equal? Let's use Desmos. And when I do Desmos, I get an undefined answer. Why is that? Undefined. Why is that? Well, let's think about this for a second. What this question asked for was what angle would produce a sine of 1.37. Now, you may remember from the last slide, you may remember from your work on unit circles, but if we're talking about the sine function, we're never going to see an output larger than 1 or smaller than -1. So when we do an inverse sine, remember inputs and outputs reverse. So because we never expected an output larger than 1, we can also not expect to have an input for the inverse sine that's larger than 1. And if it is, then it's just not possible. And we say that it's undefined. Now let's look at an example where we're asked to solve the triangle for an angle theta, where we will have benefit in using a calculator. In this particular right triangle, the right triangle has a base of 9, it has a hypotenuse of 12, and it has an angle theta that's between those two side lengths. So in relation to theta, the side of 9 is adjacent to theta, and the side of 12 is the hypotenuse. So I'm going to use the ratio of cosine. I'm going to say that cosine of theta is equal to 9 over 12. And I could maybe reduce that 9 over 12 to 3/4, or I'll just call it 0.75. Now, how do I get that theta, that argument, outside of the cosine? How do I get rid of the cosine? Well, in any sort of solving that you do, and let me just for a second take you down memory lane here. What if I said to you, solve 2x equals 10? Same idea. How do you get this x by itself? Well, you apply an inverse to it. Instead of 2 times x, you would do the inverse, the multiplicative inverse, and divide each side by 2. That's exactly what I'm going to do for the cosine. I'm going to apply an inverse. So I'm going to apply cosine inverse to each side. I'm going to apply it to the left, and I'm going to apply it to the right. All right, now cosine inverse of cosine, they undo each other, they're inverses, so I'm left with theta. And theta is going to equal whatever inverse cosine of 0.75 is. I'm going to grab my calculator, and when I put that into my calculator, I got, let's see here, I got in degrees, I got 41.4096, I don't know, 2211 it looks like. Make sure you pause the video and see that you get that same answer. I'm going to go ahead and round this to, let's just say 2 decimal places. So I'm going to say that theta is approximately 41.41 degrees. And that makes sense to me because, again, I know that when I apply an inverse, what I'm asking myself is, what angle produces a cosine of 0.75? And for cosine, that angle has to be between 0 and 180 degrees. Between 0 and 90 degrees are my positive ones, my positive outputs, and 90 to 180 degrees would be my negative outputs. This one had an input of 0.75. Now remember, 0.75 is the output of the original cosine function. And because that's positive, it makes sense that this angle measure did end up in quadrant 1.